Hi students, today we are going to discuss about phase equilibrium. In the heading itself it consists of two words, one is phase, the other one is equilibrium. First coming to equilibrium part, what is equilibrium? Equilibrium is a state of balance. We can say equilibrium is a state of balance in general. When we take it into consideration, there will be an equilibrium, there will be no change in its equilibrium according to time. There will be no change in the reaction according to time. We can say that state is known as equilibrium state. Equilibrium is of two types, one is physical equilibrium and another one is chemical equilibrium. Physical equilibrium. Physical equilibrium is an equilibrium between two phases, which is that we can visibly notice the equilibrium between two phases. The other one is chemical equilibrium. Chemical equilibrium is a point at which the forward reaction is equal to backward reaction, or otherwise the number of reactants is equal to number of products. There will be an equilibrium. That equilibrium is known as chemical equilibrium. Chemical equilibrium occurs in the chemical reactions. We can see the example for physical equilibrium. When we take water and ice mixture, there will be an equilibrium between solid phase. Ice is in solid phase and water is in liquid phase. These two phases, there will be an equilibrium between two phases. That equilibrium is known as physical equilibrium. Example for chemical equilibrium is a formation of ammonia. When there is a formation of ammonia, nitrogen and hydrogen is involved. The rate of forward reaction will be equal to the rate of backward reaction. That reaction will be expressed in equilibrium. Equilibrium symbol is this, double arrow symbol. Okay, the next one is phase. When we come into the phase, what is phase? A phase is a homogeneous and physically distant part of the system. A phase can be differentiated by mechanical or any other surface boundaries. These phases can exist in two forms. One is heterogeneous phase and the other one is homogeneous phase. First we come into the homogeneous phase. Homogeneous phase, when we take two phases solution. When we take solution and we are doing reaction, that solution is completely miscible, means it forms only one phase. That is homogeneous phase. For example, when we are taking two liquids and it forms only one solid phase, that phase is known as homogeneous phase. For example, that solid is characterized into two types. One is single phase solid and the other one is multiple phase solid. Single phase solid means a crystal, a pure metal comes under single phase. For example, a crystal comes under multi-phase. Crystals, polymers are all comes under multi-phase. The other one is heterogeneous phase. Heterogeneous phase means a reaction, two phases or two substances or two liquids are reacting, but they are immiscible, means they form another one, they form some other phase products. That is known as heterogeneous phase, because for example, when we are mixing two liquids, these two liquids are immiscible. For example, we are mixing CCl4 with water. Both are in liquid phase, but these two are immiscible. So the product will be like this. This is CCl4. Because the density of CCl4 is higher than that of the density of water, so it goes down and the water is in upside. There will be existence of two phase. This is the example for heterogeneous phase. Phase rule. Phase rule is introduced to explain about heterogeneous phase, which was given by J.W. Gibbs. Thermodynamically, he gives a mathematical expression F plus P is equal to C plus 2. Here F is the degree of freedom, P is the phase and C is the number of components present in that system, and 2 it is digital representation. Okay, coming to the term component. In that phase rule we are using the term component. Component means number of independent chemical species present in the system. For example, it may be an element, it may be a metal, it may be any other compound or anything, but it should be an independent chemical species. For example, when we take Al, aluminium plus copper alloy, it consists of two elements. One is aluminium and the other one is copper, but it exists in a single mixture. It exists in an alloy. So the components of this aluminium copper alloy is 2. It is a two component system. Okay, coming to the next factor, F. F is a degree of freedom. It is also known as variance of system. Degree of freedom is defined as the number of external and internal factors present in the system, which means the temperature, pressure and concentration. These are the independent factors in the system. For example, when we are saying that when the system is in equilibrium, the temperature and pressure does not depends upon the equilibrium. If we are changing the temperature and pressure, the equilibrium will not change. That factor is known as independent factor. Number of independent factors is degrees of freedom. The other term is structural constituents. Structural constituents means in the word structural itself it says about the structure. There are number of phases: solid, liquid, gas and many other phases like glassy, plasma phase, like etc. When we are saying different phases contributes different structure. Depends on the phase, it forms a structure. So structural constituents means the structure distribution of phase. Okay, coming to phase rule. Phase rule, F plus P is equal to C plus 2. 2 denotes the independent variables. Temperature and pressure is independent variable. Okay, when we are taking a water system as an example, we are taking water a component. Water is one component system. So one component, water is only one component, H2O. Water is only one component, there is no other element present here. And water can exist in three forms: ice, liquid water and vapor. Solid phase, liquid phase and gas phase. It can exist in three phases. So for water system, the number of phases will be 3, the number of components will be 1. Water is only one component, so number of component will be 1. So the degree of freedom we can calculate from phase and component. If we are knowing the phase and component, we can calculate the degree of freedom. F is equal to P here moves on another side, it will be negative charge. So C minus P plus 2, C is equal to 1 and P is 3 and P is 3 plus 2. Number of independent variable, temperature and pressure. So the degree of freedom for water will be 0. If it is 0, the degree of freedom we can say it in an invariant. For example, if the degree of freedom will be 1, degree of freedom will be 1, it is monovariant. If F is 2, we can say it is a bivariant. Another example for there will be a difference between component and phase. For example, we can take aluminium and copper alloy. Okay. In a system, it exists like this. For example, in a system, it exists like this. In aluminium and copper alloy, how many number of components are present? It is 2. One is aluminium, the other one is copper, so 2. Number of phases will be, one is in solid, the other one is in light. This phase is dark, compared to this. So this is one phase and this is another phase. So number of phases will be 2. The phase rule for this will be F is equal to, number of components will be 2. One is aluminium and the other one is copper. Phases will be 2. One is lighter side and the other one is dark. Okay, so number of degrees of freedom is equal to, number of components will be 2, number of phases will be 2, and independent variable. Independent variable we can say it is 2. So the degrees of freedom will be 2. It is bivariant. That's all. Thank you.